Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into it.
The spar is the basis of the design of most passenger cars. It holds the aggregates, and it is he who takes most of the loads. Longerons in the car are arranged in pairs, connecting with lintels, so a load-bearing structure is formed which provides the rigidity of the body. Most body elements and some aggregates of the car are attached to this frame. If you look at the design, you can see that this detail resembles a ladder, in the jargon so-called the spar of the car. What it is and what its purpose is, we will tell you further. In terms of strength and reliability, spars are difficult to compare with something else. They are designed for extremely heavy loads, which are created not only by the weight of the car, but also by driving on our roads. They are able to endure for a long time shock loads that are created when the wheels hit potholes. Functions performed by the car spar. The term itself comes from the French language, where the word means to move along something. The term is applied to many engineering structures of this kind, used in railroads, aircraft, and even ships. A load-bearing structure of this kind is present in most automobiles, except for those cars where the load-bearing element is the frame. In classic passenger cars, the spar extends along the body and strengthens it in places where passengers sit and heavy elements of the car are attached. In a way, the spars act as a damper between the body and the suspension. Some of the energy absorbed from the road that could be transferred to the body is dampened by the supporting structure. If the body was so rigid from the outset, the occupants and driver would absorb each impact much more strongly than they would with such a structure. Therefore, to prevent such an effect, the front end of the car is made so that it can somewhat soften the shocks, and not just be totally deformed by them. Special structural solutions are provided in the design to accomplish such a task. These are provided in various ways. In some places, the spar is slightly reduced in thickness and the width of the section is changed. Technological holes are made in those places that bear the minimum static loads. Special folds are created which, in the event of a severe impact during an accident, allow the vehicle spar to be crumpled. Due to this, there is less damage to the body, in which there are people. The supporting structure absorbs kinetic energy and takes on all the load. The impact transmitted to the cabin due to this is much weaker. Each of these types is often found on quite unexpected vehicles, even trucks and SUVs. The first type of construction is more typical for a vehicle with increased off-road capability. Due to the vertical arrangement, designers managed to make a flat floor, significantly reduced in comparison with classic cars. Almost the same effect for the curve and horizontally curved spars, only at the expense of this also increases passive safety. As you can see on the photo of the bottom of most cars, between the spars there are also cross members. They are a kind of body stiffeners. They are placed in different ways, perpendicular to the spar, X or K-shaped. In most cases, the cross members are made of steel profiles, bent at the desired angle. If we consider a passenger car, then in it the crossbars are welded, in the truck are fixed with rivets. Special brackets are attached to the spars, on which the car units are then fixed. Pros and cons of the car spar. A huge advantage of having a spar structure in the car is that it creates the necessary rigidity with a light weight. The light weight provides an increased level of controllability. The car becomes more maneuverable. Maximum passive safety is ensured due to the presence of some design solutions, which we talked about above. But there are certain disadvantages. Each vehicle unit, engine, gearbox, etc. is attached to a spar. Due to this, mutual connection is ensured. And if the body is damaged by a strong impact, then the technical elements also suffer, because of the peculiarities of the design. Spars are rarely, when repairable. The main problems of the car associated with the spars. The main problem with this design of the car is that over time the metal succumbs to the fatigue effect. Because of this, after 10 years of seemingly strong design in reality may not be at all. In conclusion, the purpose and design of spars play a crucial role in the structural integrity and performance of various engineering applications, particularly in aerospace and marine industries. By understanding the principles behind their design, we can appreciate how spars contribute to strength, stability, and efficiency. As we continue to innovate and push the boundaries of technology, the evolution of spar design will remain essential in creating safer and more effective structures. Thank you for watching, and we hope this exploration has deepened your understanding of this vital component in engineering.